Hi, hello, welcome to Homeschool. This is your class 9 Mathematics NCERT or CBSE board. We are in our chapter 7 Quadrilaterals, exercise 7.1, fifth problem. Show that if the diagonals of a quadrilateral are equal. Okay, let us take a quadrilateral here. A, B, C, D is a quadrilateral. The diagonals of a quadrilateral are equal. What are the diagonals here? Identify. AC and BD are the diagonals. They are saying that diagonals are equal. AC is equal to BD. And bisect each other. Bisect each other means diagonals AO is equal to OC and BO is equal to OD at right angles. Okay, and these diagonals bisect each other and they are all right angles. Right angles, then it is a square. Okay, what is given here? They have given a quadrilateral. They said that diagonals are equal and they bisect each other at right angles. Then it is a square, means prove that this quadrilateral is a square. How can we prove, children? The diagonals equal and bisect each other and they are right angles. Before session, what we have done last problem, its converse is this problem. Before problem, given a square, we need to prove that diagonals equal, diagonals bisect each other at right angles. We tried to prove in 3 cases. Right? Its converse is this one. So, we remember a statement that is, in a quadrilateral, if diagonals equal, bisect each other at right angles, then I say that it is a rhombus. If it is a rhombus, then all sides are equal. According to that statement, I say that all sides are equal. All sides equal, I say it is a square. No, it's not enough. If all sides equal and they are perpendicular, we say it as a rhombus. Then to prove it as a square, we need to show the angles perpendicular. Right? Is it clear? Let's start our solution with the given data. Solution. Given A, B, C, D is a Given ABCD is a quadrilateral. Diagonals are equal. Diagonals are equal means what, children? AC is equal to BD. And your next statement, bisect each other. Bisect each other. Which are going to bisect? Diagonals bisect each other. That means AO is equal to OC and BO is equal to OD at right angles. Means you can say that the angles are 90 degrees. If you want, you can write only one angle or all the angles also you can write. I may take any one angle. Angle COD is equal to 90 degree. Okay. What we need to prove? To prove quadrilateral ABCD is a square, I need to prove here. Okay, let's start a proof by a tiny statement. That is, if the diagonals of a quadrilateral, are equal and bisect each other at right angles. Bisect each other at right angles. It is a rhombus. How can I say this statement? We have already proved before problems. What is that? If a quadrilateral diagonals are equal and bisect each other at right angle, then it is a rhombus. Then according to this statement, I can say if it is a rhombus, then all sides are equal. Write that statement. AB is equal to BC is equal to CD is equal to DA. Then immediately you may remember, ma'am, all sides are equal. We can say it as a square. No. All sides are equal. It might be a square. We need to prove. How can we prove any angle? You prove it as a 90 degree. Right? So for that we are going to consider two triangles. Consider triangle ABD and triangle ABC. Observe the triangles carefully. If you want, you can take out side by side and you can split and draw. Any way you can do. So look here carefully. DAB. And I'm going to take another one, CDA. These are the two triangles from this figure I'm going to compare. We know diagonals are equal, children. Then I can say DB equal to AC. AB equal to AB. Why? Common base. And by this statement, I say that AD is equal to BC. AD is equal to BC. Therefore, by SSS congruency rule, I say that the two triangles are congruent. If they are congruent, I can say the two angles are equal. Let's start comparing here. ABD triangle. AB is equal to AB. Why? What's the reason? Common. And next one. BD is equal to AC. Diagonals are equal, that is given. So you just write given. And one more. AD is equal to BC. This statement already we have proved. So I will write here as proof. By proof, I say that AD is equal to BC. Therefore, continue your problem here. Okay. Continue the problem. Therefore, triangle ABD is congruent to triangle ABC. If they are congruent, by which rule, children? SS rule, I say these two triangles are congruent. By CPCT, I am going to equate the angles. Which angles I will equate? This one. Angle BAD is equal to angle ABC. Angle BAD means this angle is equal to ABC. Now I remember a statement, that is co-interior angle sum will be supplementary. Let us check it out. That is angle BAD plus angle ABC is equal to 180 degree. We know that angle BAD is equal to ABC. Substitute instead of BAD ABC. Angle ABC plus angle ABC is equal to 180 degree. Since by above angle BAD is equal to angle ABC. According to this, I have substituted angle BAD is equal to angle ABC. Add these two times angle ABC is equal to 180 degree and send this multiple to other side. Let me continue your problem here. Angle ABC is equal to 180 degree by 2, that will be 90 degree. Okay. Therefore, angle ABC is equal to BAD, children. This I got 90 degree, right? Angle ABC 90. That means ABC and BAD angle is equal to 90. Therefore, what we have proved here, this is 90, this is 90. Similarly, if we take other two triangles, I can say other two angles 90. So, you can end up with the same statement here, children. That is, we have proved this, right? Therefore, hence, if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. We can end up with the same statement, or instead of this statement you can say that hence it is proved. Okay, understand here carefully. What is the problem given? A quadrilateral ABCD, diagonals equal, bisect each other at right angles, prove it as a square. So immediately you remember that if diagonals equal, bisect each other and right angles, if it satisfies, I say that this quadrilateral is a rhombus. If it is a rhombus, all sides are equal. Then write that statement and now compare any two triangles such that you take this triangle and this triangle. Common base, diagonals equal. According to rhombus, these sides are equal. Therefore, by SSS congruency rule, the two triangles are congruent. Then you should think a little. If they are congruent by CPCT, corresponding angles are equal. If those angles are equal, then co-interior angle sum will be supplementary. If they are supplementary, then if you substitute this one, you are going to get 2 times and angle ABC is equal to 90 degree. If this is 90, this will be 90. If you prove 2 angles 90, you can say that it is a square. Let's see the sixth problem. Diagonal AC of a parallelogram ABCD. Look here, ABCD is a parallelogram, diagonal AC. Bisects angle A. What do you mean by bisects angle A? Angular bisector. This diagonal bisects this angle. That means this angle is equal to this angle. Okay, angle A is bisected by the diagonal AC in a parallelogram. Show that it bisects C also. Show that it bisects angle C. We need to prove that one first case. And your second one, ABCD is a rhombus. We know that ABCD is a parallelogram. Prove ABCD is a rhombus. So how can we prove this, children? Let us think over here. These two angles are equal. Then now parallelogram said. Parallelogram means opposite sides are parallel. If a line is drawn between two parallel lines, then it acts as a transversal and their alternate interior angles are equal. So look here, this angle is equal to this angle and this angle equal to this angle. Right? If you compare these angles, you can say this equal to this. Then angle C is bisected, you can prove. Then what about your second case? Prove it as a rhombus. To prove it as a rhombus, you can prove any two sides equal. If two sides equal, you can say, then I can say it is a rhombus. Okay, let's start our solution. Given ABCD is a parallelogram. ABCD is a parallelogram. And what did they give here? Angle A bisects. That means angle DAC is equal to angle BAC. Observe the angle DAC is equal to angle BAC. Angle A is bisected. So according to that, I can say that angle DAC is equal to angle BAC. Angle A is bisected. Now, I can say that if ABCD is a parallelogram, I can say opposite sides are parallel. AB parallel to DC and AD parallel to BC. Now I take AD parallel to BC. If these two are parallel, can I equate their alternate interior angles? Yes, this acts as a transversal, diagonal act as a transversal and their alternate interior angles will be equal. According to that, I say angle DAC is equal to angle ACB. Angle DAC is equal to angle ACB. Now compare these two children. Mark this one, mark this two. Okay, DAC is common. Then you can equate these two, no? Now angle BAC is equal to angle ACB. Angle BAC is equal to angle ACB. These two angles are equal, we proved. So now mark this as 3. These two angles are equal. Angle BAC is equal to angle ACB. Mark it as 3. Did we complete our problem? No, we did not complete. We need to prove this one, right? So now take another set of parallel lines. That is, here we have taken AD parallel to BC. Now you take another set of parallel lines. If we take AB parallel to DC, right? Then their alternate interior angles will be equal, no? Now write down angle BAC. Look here, these two are parallel, means these two angles are equal. That is, angle BAC is equal to angle ACD. Mark this as 4. Okay. Now look here children, compare 3 and 4. What you can see? From, look here, this one and angle BAC both are common. If these two are common, you can equate these two, no? Angle ACB is equal to angle ACD. Yes, this is the thing we need to prove here. Angle ACB is equal to angle ACD. Therefore, what is the line we are going to write here? Hence, diagonal AC bisects angle C. This is only the thing we need to prove. Diagonal bisects angle C. Okay, once again look here carefully. What did we do here? Given parallelogram and a diagonal is given. The diagonal bisecting the angle A given here. That means this angle equal to this angle. Now in a parallelogram, opposite sides are parallel, we know. I have taken these two sides are parallel. Then if these two sides are parallel and this is a transversal, this angle equal to this angle. Then if you compare these two, you are going to get angle BAC is equal to ACB. Now take other two parallel lines and equate other two alternate interior angles. Then when comparing these two, we say angle ACB is equal to angle ACD. If you want comparing equation 3 and equation 4 also, you can write. Okay, comparing these two, we get angle ACB is equal to angle ACD. That means the diagonal AC is bisecting angle C also. Not only angle A, angle C is also bisected. Hence, it is proved for the first one. Second one, prove that ABCD is a rhombus. How we can prove, children? So here, by equation 3, look here, angle BAC is equal to angle ACB. So now let me start here. From second case, I am going to start here. From equations, angle BAC, second proof I am going to start here. From equation 2, angle BAC is equal to ACD. Suppose if we take this triangle, this is a common side, right? And these two angles are equal. In a triangle, if two angles are equal, what do we know the statement? Their opposite sides are equal. So by that I say here, in triangle ABC, in triangle ABC, angle BAC is equal to angle ACD. And what you can say here, children? If two angles are equal, their opposite sides are equal, right? I write here AB is equal to BC. How we can write? In a triangle, if two angles are equal, then their opposite sides then their opposite sides are equal. From this, what I can say here, if these two angles are equal, their opposite sides are equal. Now AB is equal to BC I got. Therefore, in a parallelogram whose adjacent sides are equal, in a parallelogram whose adjacent sides are equal, then it is a rhombus. Then it is a rhombus. If adjacent sides equal, then it is a rhombus. Hence, it is proved. Once again, observe the figure carefully. Given ABCD is a parallelogram, a diagonal AC bisects angle A. Prove that it also bisects angle C and show that ABCD is a rhombus. So first thing what we have done, we have taken this angle equal to this angle. Angular bisector means these two will be equal. And if it is a parallelogram, opposite sides are parallel, then according to that alternate angles will be equal. Taking opposite lines in a parallelogram, they are parallel, right? So if they are parallel, their alternate interior angles will be equal. Then compare these two. You are going to say angle BAC is equal to angle ACB. Then again, another pair of alternate angles you take here and then compare these two. What you are going to get? These two angles are equal. That means diagonal AC bisects angle C also proved. Then next I need to prove it as a rhombus. How can I prove rhombus? If you are able to prove adjacent sides equal in a parallelogram, then it is a rhombus. So take any one triangle. Now you have proved this angle equal to this angle. Okay, from equation 2. If these two angles are equal in a triangle, what we remember a statement, if two angles are equal, their opposite sides are equal. That means AB equal to BC. Okay, if adjacent sides are equal, then this parallelogram is a rhombus. Okay, understand these problems carefully and solve the problems now itself. We are going to end this session. In our next session, we are going to continue with the next 3 problems. Until that, keep watching. Thank you all.